Okay, so let's get started with the Visual Studio tutorial, and we'll learn how to use Windows Azure. So you run your Visual Studio as administrator because you have to run the emulator. Then we start a new project. For Azure, you want Visual C# Cloud, and you select Windows Azure Cloud Service. You give your project a name. Let's call it Demos Azure, and we'll store it in Dropbox. And the solution name is Windows Azure, which is fine. Okay. So before we get into the code, the idea is this. You can have web roles and you can have worker roles. And for this tutorial, we will only consider those two things. A web role is a virtual machine. A worker role is also a virtual machine. The difference is that the web role runs web server. So you can host a website there. You can deploy your files there. They can interact with users over HTTP. So they can just type the URL and your web role will respond. Worker role will not do that. That's the only difference. Other than that, they're the same. Then comes the part of storage services. So for any program, you have to store data. You have to store it somewhere. One way is that you can store it on the machine where the data is being processed. But on cloud, everything goes away after a certain time, right? You don't want to get a virtual machine for, let's say, 100 years or so. You want it for certain hours. You might reduce the number of machines. You might increase the number of machines. You might have to terminate your application at some point. There could be failures. So you don't want to store your data locally. You don't want to depend on data that is stored in a local machine. So you always want it to be stored at some place where you can access it later on. Okay? Even for sharing purposes, that makes sense. If you store your data in storage somewhere which is not on the machine, then it's available to everyone, right? So for this, there are three things that you could do. You could store data using blob storage. Blob storage is like your file system, traditional file system. We have blobs, which is equal to files. Then we have blob containers that are folders. You can create as many blob containers as you want, and each container can have as many blobs in it. Second, they have table storage, which is again for table, and it's not the RDBMS table that we are familiar with. It just allows you to store your data in terms of rows and columns. And that's the only difference between table and blob. Well, there are a few more differences, such as in a table, you can store 1 megabyte of data in one row, not more than that. In blob, you could store as much as you want. Third one is the queue storage. Queue storage is primarily for communication among roles. It could be among worker roles, among web role, or among web and worker roles. So that's the storage. So now let's add a web role in our project and a worker role. So I added a web role and a worker role. Let's rename them. Let's call the web role master and the worker roles slave. So these are roles, which means they define what are they going to do. So your code will go in these two parts, in web role and in worker role. However, it does not define here how many of each you will get. You can get 100 machines for each. You can get 50 instances of a web role or 50 instances of a slave, a worker role. Okay? So we don't define that here. Here we just add what kind of roles we need. There are different roles, but we are not going to get into that. And it will take a minute.
Grab some water.
So it takes a good few minutes to set up everything. It had so many things that if you are not familiar with Azure, it looks scary to see so many files. But fortunately, we will only be working with a minimal set of files among these. And most of the files we won't even touch. Hopefully we don't have to. Okay, so this is the worker role, and this is the default.aspx. If you guys have coded with ASP, you would know that default.aspx is the page that will load by default. So they have given us coding the basic code for a web role and very basic code for worker role. So this is the web role. It will have, if you see the design of this, so this is my web page that they have created for me. There are two pages, home and about. So this is about and this is default. Default is my home page, and on default they have written this: welcome to ASP.NET, blah blah blah. So that's what they have done for me. And for the worker role, they have coded a little. What they have coded is this. This is the code that happens when it is running. So this is what happens when it is starting. So you set something and then you just say, okay, you're ready to start, and then it goes into the run state, and it stays into the run state forever, or it should, or that's how you should think of a cloud-based application. So you have web role and you have worker roles, and they will continue to run forever. A web role is a website. So for instance, you go to Facebook, and Facebook will open a page to you which is served by the web role. Okay, now you type a message, you hit enter, and the web role takes that and puts it somewhere that, okay, this is what has happened, and then the worker role should take it, and it will say, okay, this message is from this guy, this message goes to this guy, I should store it there, and then I should add another message to that guy telling him that you have a notification, or all that kind of stuff. So basically your background processor will keep doing that. Now your web role, you'll do something and you'll eventually close the window. So that instance of that program is closed now, but someone else will come, and someone else will come, and someone else will come. So these things will happen, but the background worker will not be done. It will keep listening, and whenever new work comes, it will pull that work and it will process it, and it will tell that, okay, I am done. Or if you don't ask it to tell you that, okay, I am done, then it will again go back in the loop, search for more work. So that is the whole idea of a cloud-based application. You tell the worker role, the web role usually tells the worker role, this is to be done, and here is the data that you have to process. And then the worker role will know where the web role is going to put the data, so that it can read it from there, and it has the code to process that data. So it will start processing that. And once it goes through that cycle of processing, it will come back in the loop, and it will start doing again the same thing again. Make sense? So this is what they have done. So you almost always will see a loop like this, while true. So it's for that. So you do one thing, and then you go back to the beginning. So here it doesn't do that. It will just go to while true, and it will sleep for 10 seconds, and then it will put a message, a log message that it's working. Right? Okay, now we have to add something so that it makes sense. It does something. So for that, let's say we wanted to create an application where the master sends a message to the slave that, hey, do this, and then the slave does that, and then it tells you, I'm done, and then master says, okay, you're done, right? So we will write an application like that, and then we don't want it to be very complex because it's just a tutorial, right? So what we'll do is that the web role will send a message that process these two numbers. The worker role will sum them, will add them, and then it will send the sum back to the web role. Make sense? We'll do that. Now we can start coding, but let's think about the structure first. What should happen here? What will web role do? Or what kind of design would you have in your web role? There should be two text boxes for the first number and the second number, right? The user can enter. And then there should be a button that says, okay, sum these up. And then there should be another text box or a label or something that will display the result, right? So 3 text boxes, 1 button. And what happens when you click on that button?
Sort of action event listener or.
Right, so on that click event,
Yep.
what should it do on the cloud side?
Send those 2 numbers off in a queue.
Right, so it should send those numbers to the worker role. So we won't, so there is no direct connection that you can say send it to the worker. You have to put it at a space, and then you have to tell your worker the numbers will come at that space. Keep checking that space. And if you find something, grab it and process it, right? So for this, we have to use storage. We could use a blob storage. We could add a number to the blob. Or we could use a table storage. We can add the number to the table. Or we could add it to the queue. Now, if I add to a blob storage, then each blob, like a file, has an ID, right? Now, if I have to add, let's say I get 100 users to my system, they all will add their own numbers, right? Now, if I'm adding it to one blob, that file will become inflated. How will you tell your worker that take 1 number from this, or take 2nd number from this, or take 3rd number from this, right? So that is a problem. What you could also do is you can create 1 blob per set of numbers. In that case, your worker role still needs to know which file to process, because every blob will have a different name, right? So how will your worker role know what blob I should go and process? So somehow you will still need to tell it that this is the blob that you have to process. So if we go to table, yes, we could add a row to it that, okay, keep adding rows to it, and each row has this set, first number and the second number. Problem with that is, how would you know which one you should process? If there are, let's say, 20 worker role instances, so the same code is being processed by 20 worker roles, right? I don't want only one server to process all of the Facebook messages. I want thousands of machines so that the user doesn't face the delay, right? So which of those machines should read the first row? Which of those machines should read the second row? How does it work? Which one should read as we go forward? Let's say we have million users online at the same time. Who should read million and 1th customer? You know what I mean? So queue makes it easier to do that. In a queue, you could put a message, and every worker can grab a message from the front of the queue. So the queue will return a message, they can process it. And when the queue returns a message to the workers, it says, okay, no one else will read this message. If you are done with it, let me know, and I'll delete it. If you are not done with it, if the worker role dies or fails in between, then the queue will be like, this guy is not coming back. I should give this work to someone else. So when someone else asks for a new set of numbers to process, it will return those numbers again. So those numbers will pop back up in the queue if you don't return that I have processed it in the stipulated amount of time. Okay?
Kind of like the bag of tasks.
Right.
Yeah.
Right. Exactly.
Okay.
Make sense? So you see why for communication we use queue. The problem is that if you have something else, you have to make sure that the numbering is known, or the naming system is known, and you know exactly how many items are there. Queue gives this to you. You don't have to worry about it. You say, give me 1 set, and you're done. Okay?
And the queue holds the information that ties that 1 set back to the instance of the web role.
Say that again?
The queue will hold the information that's tied back to the instance of the web role.
So a queue does not care who's reading. So if I am a queue and you're a web role, you could be a worker role. You come to me and you tell me, give me a set. I don't care if you're a web role, worker role. I'll give you that set, and I'll mark that set as invisible to others. So if other role comes to me and says, give me 1 set, I'll give him the next one, because this one is marked as invisible. Now, if you don't come back to me, so when you are asking for something, you have to tell me, give me a message for this amount, duration of time. And if you don't come back to me within that duration of time, I'll mark it visible, and I'll say that you probably are not going to come back. So next time if someone comes, I'll give this message.
Okay. My question more related to if you have 10 people, 10 web pages,
Okay.
they're all doing this simultaneously,
Okay.
you're going to have 10 elements in the queue.
Right.
So then when one worker grabs that element, where does he know to return it to? What of the 10 web pages?
So-
web roles?
Good question. What he's saying is that how do you make sure that what you're submitting is actually what you're getting, right?
Mm-hmm.
So there is no way to do that.
Hmm.
There is no way to do that. You have to add that smartness, that intelligence into your application yourself. And that's what MPI did. In MPI, you could say, send this message to this worker, and then the worker could say, send it back to the master. And you could do this proper communication. In Azure, there is no way to say that, okay, I am putting this message in a queue. This is for ID1. ID1 will take it, and then it will say, okay, I am returning this message to the master, and then the master will know that ID1 has returned it. So you cannot do that. For that, what you could do is that you can create one queue for every combination. So if you have 10 web roles and 10 worker roles, you could create 100 queues, and then you do a matching. But that's all messed up, right? You don't want to do that.
Yeah, that sounds very convoluted.
So basically, cloud was created for applications where you didn't have that requirement. Cloud was created for batch processing. I mean, in Facebook, you read a message or a text that someone has entered, you store it in that person's ID, you get the ID, and then you see who else is mentioned in that, and then you send them a message. You add a message in theirs, and you're done. You don't have to tell back that you're done. The web role will keep updating. It'll keep looking in your account in the information, and it'll keep pulling information from there. So as soon as it is updated, you'll see it on your front page. So no one has to tell no one that I am done or anything. You know what I mean?
That makes sense, yeah.
Yeah, so that's what cloud is made for. It's not made for point-to-point communications. Okay, that was an excellent question. So we need a mechanism to store data. You have something? Okay.
He's like, I'm smart. I'm like, for now. Just wait.
So we need a way to store data, right? So for that, you have to add references. And add reference, sorry. And then here we want to add references from, let's sort it by name.
What's it called?
Microsoft.Windows Azure dot. So I'm just trying to sort it by the
Ah.
component name, but it's still loading the list because it's a long list.
In 2012, you have the ability to search what you want,
Ah, interesting.
which is a nice little.
Yeah, it's Microsoft.Windows Azure dot storage and service. You have to add 3 or 4 references.
Microsoft.Windows.Azure. Just in the framework.
No, here. So Microsoft.Windows Azure dot diagnostic. Then there should be storage. I don't see storage here. Yeah. So diagnostics, storage, then service runtime, and so storage client was old. We are not going to use that. And yeah, that should be good.
Diagnostics, service runtimes. Doesn't matter which one. Or obviously, it's the most recent version.
No, oh well, never mind. It seems it already added that for us. Did it? Oh yeah, it already added. Interesting. All good. But we don't want this storage. Let me see its properties because some of them are old. So yeah, we don't want the storage client, but let's keep it for now. Alright, so when we added this project, they add these references, and we should be fine with this if the version is correct. So this is correct.
Just like libraries.
Yeah, these are libraries.
Okay.
They have all the code for Azure.
All right.
Now we have the references. Now we also need some code to connect to the table, the account, and do stuff, right? So for that, what I'm going to do is we have our own libraries that we have created here. Or let's add those.
Excuse me, which references you have?
So let me open this.
Storage?
Yeah, configuration, diagnostics, service runtime, and storage client. And let's add storage at least. We will need that. Storage is a 2.0, so that's why it's better than storage client if I can get it to work. Let's see. And I guess few days ago, just like last week or something, they introduced yet new version of these libraries.
Breaking everything, I'm sure.
Oh yeah, it breaks. Yeah. So we'll add storage. And so I just added storage as well. Now I'm going to add those projects to our solution. And you don't have to worry about it because we already have that, so you could also take it from there. No, this is this, that. Let me see if this is what it is. Okay, basically I needed this and that. So I could remove, I'll need this as well. So let me remove this. So we don't need others for this one. So this is a class called blob helper. It has different functions such as this: blob client, copy blob, delete container, and everything that you could do with blobs: list containers, put blob text, put blob, and everything that we could need to write something to Azure or read something from Azure. Okay, so we don't have to code it again and again. And then similarly, queue has something similar here. List of queues, get message, put message, and stuff, right? So you'll just reuse that. So the advantage of this is when they introduce a new library, you add the new libraries and you change this class based on what are the breaking changes, and you're done. You don't have to change your code, right? And once you change this, you update all your projects. Alright, so here let's fix the name spacing. So we don't want to call it GPC overlay, we'll call it Azure helpers. And we'll change its namespace to, should we call it
Could do that for you.
get it?
The IntelliSense doesn't really work that well on mobile.
Here. Is that what you meant?
Well, yeah, I thought when we would rename the folder, it would rename all the namespaces.
Got it. Oh, you thought it'll do it automatically? I guess you still have to say, okay.
Refactor or rename.
I guess something like that.
It doesn't, well, when you make a change like that, you can tell it to like, yeah, you just change this, do you want me to fix it so it doesn't break?
Yeah.
That's fine. I mean, no big deal.
They've done a lot.
Oh, it did it for this one.
Huh.
I don't know why I didn't do it for these two. Maybe I changed it myself. Oh no, we did it through that. Change it to everything.
Okay.
So you at least have to make one change, and then you can say change it everywhere.
Okay, gotcha.
That makes sense. So here, basically, these are constants. So I have these names, and we'll change it. These are for the other project. But if we have to change it, we'll come back to it and change this. So here are my blob commands. On the master, let's go to our default.aspx page now. Let's go to the .aspx. .cs is where we write the code. So design, properties, but toolbar. So we wanted what? We wanted 3 text boxes and T here. As you can tell, I'm not an ASP user. Alright, let's do it better. So I don't want this. Welcome to ASP.NET. To BH2. What I do want is the type here. And then I want button here. Oops. I want another text box here. Can I write something here? Let's say, we'll call it number 1. Where does that go? Okay, that looks good. Let's change the IDs. This is not the one. Okay, now when someone clicks, let me add on something should happen here. And for that, what we need is we will have to tell this that we are going to use this project in this one, right? So our master project is dependent project dependency. It is dependent on Azure helpers. Okay? So that way it will know that we have to use some classes from there. And then I can say using why didn't that work? Can I compile it? So we probably won't need this one because it deals with blobs. Where am I using that? Let's see. Can I delete this? Oh, come on. That is weird. Any idea why is it doing that? Am I using GPC overlay here?
Doesn't contain a static main method suitable for an entry point.
Sorry?
I'm just reading down at the bottom of the screen.
Let's see. Contain a static main method suitable for but where is GPC overlay.exe? We shouldn't have that. see if I can delete this one. Alright, you know what, let's do it differently. Let me remove this. And what I'm going to do is add a new project, and it should be cloud based. Let's call it Azure Help Tool. I don't want anything in this. Oh, that's not right. I want to add a new project, but not an Azure project this time. We just want a library. Class library here. Azure helpers. So it has class1.cs, and we could actually remove that. And now we can add items, and we'll bring those two things. Say queue helper, and so now this one doesn't have those references, so for this we need to add those references for Azure. And hopefully these will be fine. So we need the storage client as well. You won't have to do this, because for the projects that you're going to work with, I have taken care of all this. So they are currently in the running state. Service runtime, very nice. Did I not add service runtime? I haven't. Okay, so it hopefully will work now. If not, we'll go back to the other solution. Oh, come on, seriously. Probably don't worry, we'll figure this out. Shouldn't be a problem. So now let's do some code, and now we add what dependency. Come on. Add a reference to the projects. That will help me. So we don't need this. So on the button click event, so one more thing, let's do that. So for master, for each role, you have to specify how to connect to Azure. Okay. So you double click on this. You go to settings. Let's go to configuration first. VM size is small, and this is fine. So there are 5 different sizes, and I guess they are coming up with 2 more. But for this, let's say small is what we need here. Small is 1.75 gigabytes of RAM and 1.6 gigahertz processor, single core. This extra small is shared processor. This is single core, this is dual core, this is quad core, and this has 8 cores. And then the memory goes up as you move forward. And settings. So for connection string, we'll be using our account on Azure. So your subscription. So I already have this stored in on this machine. That's why it picked it. Otherwise, you would have to get another one. And I'll change these connection strings because if you plan to put this video up, but you guys will have it. I'll give it to you. Same thing for slave. Go to settings and this one, and you can say okay. And we say save it. So we did these 2 things, and then we could copy this connection string here and we say Q helper Q equals to new, and then it will take that connection string here. That to make it easier, let's create here private. So connection string.
That's the connection string you got from the worker.
Yeah. We just copied it from there, right? So web role and worker role both will have the same connection string because you are essentially connecting to the same account and the same storage account. So we create a new queue helper, and we probably won't need blob, so let's work with queue. And then you say queue. Now on page load, let's do this. Queue dot queue. Come on. We want to create a new queue. That's in the static method. So queue dot. We want to create a queue, and then the name of the queue should be from. Let's create a new. Or let's make it simple. My queue. So there are some restrictions on the queue name. It has to be all lowercase, and it shouldn't have any weird characters in it. It shouldn't be too long. So just read up on that. I have these details in, I guess, my paper, or if you search on Google or Bing, you'll find that. Queue dot. We have the create queue and clear messages. So clear messages in case we are running it again and we have something left over from previous run. Now queue dot.
So this doesn't run asynchronously, does it?
What do you mean?
One of the big things they did with Windows 8 and their, at least my expectation is they're going to start transitioning all of their stuff to, is that Windows 8 runs mostly, instead of running synchronously, it runs asynchronously.
Right.
I'm wondering if they're going to start transitioning their cloud, their Azure Cloud stuff to run asynchronously.
I mean, you could code it to run that way. I mean, it's just how you code it.
Okay.
I am not much into asynchronous stuff because it's pretty. So there is a learning curve. Let's put it that way. So I never got through that, so I don't do it that way. But if you know how to do this, you could do it. It's not a problem. It's just your coding style. Cloud doesn't help or uh,
Well, I mean,
give you
like-
obstacles when you
my-
want to do
my-
that.
My concern is that, I mean, you've done a lot of work on this, and like nearly all of the libraries that you access to build an application in Windows 8,
Mm-hmm.
you have to use them asynchronously now. They're forcing it down people's throats,
Uh-huh,
which is
uh-huh.
really one of the reasons I don't really tend to like coding in Microsoft. It's because they force design decisions on people
Mm-hmm.
because there's like it's better, and while it may or may not be, it's not nice to be forced to do something a certain way.
I
I'm just kind of
understand.
curious if you can do this kind of stuff asynchronously, then it is a big deal. It's just something like that.
Right. Yeah. So there is nothing that stops you from doing that if you want to do that. But it's just that I don't know literally how to do a good code using asynchronous methods. So that's why I don't do it. So I'll add a reference to storage. And I guess I have to say specifically queue. Let's say queue.provision. So that gives me cloud queue message. We'll create a new message equals to new cloud queue message, and then we have to specify what we want here. What we want here is a num1, and then the text, whatever is written in the first one, plus let's put a bar as a delimiter, and then we want whatever is in the second one. So I just created a message, and then I'm going to put this message into this queue, which is my queue, comma, it needs the message, which is my message. What happened? Some invalid arguments. So with this, so it needs storage client. My bad. So I'm using the old libraries in those libraries. The files that I added, they are using the old library, so I went back to the old one. But I do have some that uses new, and probably my MPI libraries and the Azure Cloud libraries, they should be having the latest one, so it shouldn't be a problem. But that's it. We just put a message in the queue. Okay. Now I'm done with half of the thing. I have read whatever the user gave me, 2 numbers. I put them on a queue. Now, what is the second half? Second half is I want to get the result, right? So, as Michael said, I should do this asynchronously. So whenever I have the message, I should just get it. So one thing I could do, not asynchronous, is I could add a button that says get message, and it will tell you if the message is available or not, if the result is available or not. Or I could just code it here while true, and I'll keep checking for these message. If I get a message, I'll just print it and come out of this loop. Otherwise, it'll just keep checking that. Now for that, I'll create another queue, because you see, I cannot have the same queue for 2 things. This is not how it works. Queue should be a one-way traffic. You can't use it for 2 ways. The problem with that is, let's say you have tens of things, right? And you want to put stuff there, and you want others to finish those 10 things, and then you want to start reading the results. How would you know if those 10 things, or if the things that you see in the queue are the results or the input data? So you cannot distinguish, right? So that becomes a problem. So you always want the queue to be separate for every operation. So let's call it result queue. And this is the result queue. While true queue dot get approx message count from, let's create int message count. I'll code it result queue comma out message count. So it'll get me the message count if message count greater than 0. If we find a message in the result queue, in that case we will read it. Queue dot get message the result queue comma, and let's store it in message. Why do we care, right? We don't need message anymore, so we could use reuse the
Could you store it directly in the text num3.text?
sorry.
Could you store it directly back in the text box?
So it throws it. So you see there is an out here.
Mm-hmm.
So how do you want to do that?
Just put it directly back in the text box.
No, but it doesn't return anything. It returns you true or false. This get message. You know what I mean?
Okay.
So it tells you if it got the message or not.
Oh, okay.
It doesn't give you the message text. You have to put it here. So then we'll say.
So basically, while it's still returning messages, just keep doing the while loop.
So I'm only going to do the while loop if I don't have the message yet. If I get the message, I'll just come out of the loop. So you put two numbers, you hit sum, and then it goes into sum. It puts the message in the queue, assuming that the worker role will read that message, process it, put the result in the result queue.
Yeah,
So while the web role will keep polling on the result queue. That do you have the result here? Do you like it's a
it's just like when it's just the while true.
yeah, it
It's
gives a
when
wrong
it's-
message. Yeah.
Yeah, I'm just wondering what the termination condition.
Right.
is.
Let's see. We could do it this way. Does that make more sense?
Yes.
Okay.
Some people use while true a lot. It's just
Yeah,
it's
it's
just one of those things where I'm just like, I only use while true when I'm actually putting a condition that pulls a break. Like it actually does a hard break.
Now here is something for a complex project. If you are working on a complex project, this code will give you errors you cannot debug. I promise you. This is a correct code. If you have a small project, it will never produce any error. You'll be fine. But if your project is large, complex, and you code this way, there will be an error you'll not be able to debug. I promise you. It took me like 2 months to figure this stupid thing out. The problem is, if you query too hard and too fast, you'll throttle the storage queue, and it just doesn't know what to do. And it will throw some error sometimes, and sometimes it'll say unhandled exception. Because it's unhandled, you don't know what is the error about. So if you don't find a message, for God's sake, we'll do this.
Yeah. Something that they don't put their documentation on.
Yeah. They do, but they don't highlight it because
Yeah.
it's something, They don't want you to do
It's
it.
not the kind of thing you'd run into a lot. 'Cause
So for that,
this
okay.
seems like the thing you'd want to wrap in an exception network.
Yeah.
I just never do. Like 99% of the people that code in Java and C# just don't bother with exception handlers
Unless they
because-
have to.
unless you absolutely have to,
Yeah.
have to have one.
So this is thread.sleep, and we're sleeping for 1 second before we query it back if we don't find anything. And then this is everything we wanted to do on the web role, right? So you hit sum, it will put the numbers on the queue, and hopefully someone will process those numbers, put the results back in the queue, and you should be done. Now here, on the worker role, what you want to do is you don't want to do this. So now you don't have to do this. You want to add a reference to the project as your helpers, which you did, and you want to use using as your helpers. So here you want to create a queue. So first you need a private string connection string equals to, we need the connection string, and it is here. Then let's say queue helper, queue helper. Then we'll say if, or same thing, or just keep polling, while message count equals 3%. If the message count is 0, we don't want to do anything, right? So this is queue dot get approx message count. Which queue? My queue, right? And we store this in message count, and we want it to sleep. Yeah, because you can throttle the queue. So it's the queue, the limitation of the queue.
Okay.
So the storage queue can only handle, let's say, 5,000 requests per second, unless they have improved that this time when they. So as I was telling you that they have launched a new API, they might have made those changes as well. So it was earlier it was 500. If it goes above 500 for in a second, it'll just crash, and that's why when I had 100 instances, they'll quickly asking for this. So after I had more than 15 or 16 workers constantly polling from the queue, it'll just throw me unhandled exceptions. Microsoft support group couldn't find it. Like I filed a support request, and the people who were working it, he just couldn't find it. He's like, I don't know. And finally, I was active on these community forums, Microsoft MSDN forums, and there I was talking to people, and then just no idea what to do. Then someone said, why don't you try threads? So I had this parallel for loop that, so C# has this parallel for loop. It's like OpenMP. It'll create bunch of threads, as many as it can. It'll start doing stuff. And then he said, maybe this could be a problem. Why don't you create your own thread pool and then only allow so many threads? And I was like, does that matter? He's like, maybe you're sending too many, and maybe the queue cannot handle it. And I was like, okay, I'll try. So I tried, and that was it. So, anyways. So that's a good thing to learn, that you shouldn't be doing that. System threading.
So the problem was you were basically crashing your queue
Because I was polling too fast.
You couldn't keep up with
Because there was no
requests.
message, so it'll go back. Okay, do you have now? Do you have now? Do you have now? Do you have now?
Okay.
Like as if Q is a person who gets irritated. Don't keep coming to me. I'll let you know myself, Only
Seems
doesn't let you know.
The queue is part of Azure. It's not something you designed.
No, Q is part of Azure. Q is the queue storage. Oh,
But
this
it
queue.
seems like a real, yeah.
You mean this one?
The one that was crashing.
So the one that is crashing is actual queue, actual storage.
So it's actually a Microsoft.
Right. Even for blob,
design.
if you're reading files too fast, if you're downloading let's say your blob contains a movie, okay, and you are downloading it. If there are so many people in the world who are downloading it and you don't replicate it, it'll just crash. It will not be able to. But you see, you can only put out so many things. It has to go through the network, right? And there
Yeah.
has to be a limit.
Yeah, it just it'd be nice if they documented stuff like that. clearly, and they don't. There's a lot
But
of
documents are like 500,000 pages,
Yeah.
Yeah,
right?
there's
I
no
mean,
way.
there's no way you can find out by reading. Or if you set out reading, there are only so many technologies you can learn 10% of.
Well, no, I mean like by document, I mean they should actually put it like when you put the call for like the queue helper queue equals new queue helper, whatever. When you actually create the queue, you know how when Eclipse it pops up like the Java doc if you hover over it for long enough. They should stick it in that. So then you hover over it and you're reading through it like, why is this crashing? And then you get to the bottom and like, oh, maybe I'm pulling it too quickly. Just
Could be.
put it there so it's actually.
Or just have a message like at that end that, hey,
Yeah.
you're asking too much, you know. But I guess it's left to the programmers. Alright, so it will check the messages, and if it doesn't have messages, it'll just go back to the loop. So when we come at this point, we do have a message, right? So we'll just read it. So if you want to read the message, you have to have the message. So cloud queue message. What happened? Alright, you know what? Well, I guess I will need that. I don't think so. No, I'm not sure if my library creates a new one, but I guess it does. So let's say queue dot get message and my queue message. And I guess this one, let's see, go to definition. Okay, so let's see, queue dot get message. It doesn't create a new message for you. Message equals to. Alright, so I guess we will have to do this. No big deal. So we'll get this message here, and we need to get the message data. So we create a string. So message data equals to message dot. And add string is your friend. You have to do this if you want to get the data in the message, the actual content of the message as a string. You have to say message dot add string. You just cannot say message, and you can't say message dot to string. If you do that, you don't get the data. You get a serialized message, which is not actually the data. No, message data equals to message dot add string. Then we need to split it, right? So let's say int num1 equals to message data dot split, and split on this one, and we want item 0 in this. What happened? Make sense? And then we have number 2. So we split it into two parts, and then we read part 0 and part 1 into number 1 and number 2. We say sum equals to num1 plus num2. Instead of that, we could just say q dot put message, and q name is result q, cloud queue message, which is num1 plus num2 dot toString. So basically I add these two numbers, convert that to string, pass this in a new message, and I put that on result queue. Okay, good enough, right? Now one thing that I have missed on both ends is that I told you that when you ask a queue give me a message, it gives you a message, makes it invisible for others, and it waits for you to tell it that I am done with it. If you don't do that, the message will pop back up in the queue, right? It becomes available for others. So for that, once we have processed this, we should say queue dot delete message.
Because even though you put it back in the result queue,
The queue doesn't know that
okay.
you have actually put this message in the result queue, right?
So
What's wrong with this?
So the queue doesn't have like normal put and pop functionality.
It does,
Methods.
but you see, so you could look at it as a good thing
Yeah, I
that
see
it
what you
goes
mean.
back up because the cloud nodes are susceptible to failures. So if it fails, you don't have to worry about it. Your message will still appear in the
I
queue.
mean, I could, yeah, I was gonna say, I could see where you would want to do it this way, just because it's the cloud.
Yeah.
But I've never worked with the Microsoft version of Qt, so.
Similarly, I want to delete it on the web role side too. So once you read from the queue, result queue, you want to delete it. Right? So every time you read a message, process it, delete it. Don't forget to do that. So that will make sure that your message will never reappear in the queue.
That's like some fun debugging.
Huh?
That's going to be some fun debugging problems.
Yeah, it could be. So for instance here, if we look at it, let's go to the definition. So this is what we have created here. The time span is about 2 hours, which is pretty long. You could have, like, if I don't finish it in, let's say 1 minute, just bring this message back. So because you know your application will take about 1 minute maximum. Because if it is 2 hours, then time span is what? Time hours means because if it is 2 hours, then it's way too long to wait. Way too long a wait, right? So this number should depend on your application. If your application is taking too long, then this number should be large. If it doesn't take that long, it should be short, because you are essentially waiting. Even if the guy failed, the message will reappear in 2 hours. So you just have to wait for 2 hours. So you always tweak this number. Although I don't want to do that right now.
What's the frequency of nodes failing?
It's rare. It's not very common, but you just cannot ignore it. If you're running application in production, you just cannot say it's rare. Like
Yeah.
it doesn't work that way.
Yeah.
But it's like, fortunately in my case, I didn't see too many nodes failing, but one failed last night. So I was working on something and it just went away. But then that could be a Windows update that
Yeah.
updates the whole thing and restarted. Because even if it restarts, your stuff is gone.
Yeah.
You cannot have anything locally. So that is one thing that could happen.
Except if it's in blob storage.
Yeah, if it is in blob storage, no one's
Okay.
going to see.
But Q goes away.
The virtual machines are virtual machines, and then they have this Windows installed on them. So they have frequent updates, and then if the update requires it to restart, they'll restart it. However, blob storage is a totally different data center. There are racks and racks of hard drives. Okay? And then that's where your data is stored. Unless and until those hard drives fail, your data is safe. You can always go back and read from there. Same thing goes for Q. But for Q, what they have done is that I am not going to keep it forever. It's not persistent data storage. I have it for this long. If you don't read this data, so this also specifies that if you don't read this message within 2 hours, it'll be gone.
Okay.
So this message will not stay there forever. This is for Q, but it has nothing to do with your virtual machine.
Okay.
So even if your virtual machine goes down, these messages will be there. So if you have 4 worker roles, so one worker roles 4 instances basically, and one of them goes down, the rest 3 will still be reading from the queue. They will still have access to all the messages in the queue. Does that make sense? So that's how it works.
Is table storage persistent?
Table is persistent,
Okay.
yeah. Queue is the only one that has this special property,
Okay.
because they wanted queue to be good for communication. So that's why they added these many properties.
Okay.
So anything else that comes to mind that we have missed here, or does it look good?
Inside the bottom click method.
Which one? Button click method? Okay, let's go there.
So when you click bottom, it will always stay inside while loop,
So
because you read the message.
see, it
and
says
message can-
while message count equals to 0, it will read from this result queue, and if the message count is greater than 0, which means this one, see, this changes the value of this. It could be 0 or 1. So if it becomes 1, then it will execute this. It will say get the message.
So the message count will be equal to 0 when you get the message. Right?
No, if you get the message, this will be 1, because then your queue had one message. So if you put a message in the queue, you have one message in the queue.
Yes.
So this will return 1, so it will set the message count to 1.
So you delete the message inside the if.
Ah, right. Yeah, good catch. So we should... Oh, you know what? No. That's fine, because we don't change the value of message count.
But in while.
See, the message count was 1.
Yes.
I delete the message, but I don't change the value of message count. While depends on message count.
Okay.
Message count will still be 1. You know what I mean? So it goes here, it checks the message count, it changes the value of this variable, and we don't change the value of this variable. It goes back here, message count is 1, it will get out. And then when it starts again, when you click on sum again, message count will be 0. Right?
How would this work with the other formulation with the while true? Like, how would you...
In that case, I would say if message count greater than 0, break.
So at the end...
And then I will put this code at the end.
Okay.
So are we ready to try it? Let me remove this. We don't need this right now, right? Let's keep it. I'm just afraid that this will not compile. Very nice, very nice. Okay, so you know what? This, so let's go to this. We already know where did I change stuff? Connection string equals to this one. Then we go to blog. Show you how to. Where's the error list? This is not right. You know, let me just grab this from the other project. I don't think it's gonna matter. So as you got. I'll just copy the queue helper and whoa, this is not good. That's all we need. Oh, never mind. We have another constructor here, that's fine. All for nothing. So we will be using this constructor. We don't need this constructor. Sometimes you feel like it. Build succeeded. Nice. So we'll run it now. So even though there is a lot of code in this project, we only need this much and this much, right? So that's the beauty of these libraries that we have created already. So we just use them and then we reuse them. So in all of the projects, I have this queue helper and blob helper, and it takes care of everything. And although this is a good design, we were able to put it in Cloud MPI in Azure Boat, and then we take it out from the project itself. So even if you're starting out, you don't have to do this either. You have these libraries as well.
It's nice. Extracts you from all that.
Exactly. And Azure Boat, even for Azure Boat, you don't even have to do this. There you just say add a message and add message to the bag and then fetch message from the bag. But internally, it uses these queue helper and blob helpers. And I'm planning to expose this to users so that if they want to store something permanently, because right now we depend on a queue. So if they want to store something permanently, persistently, then they could use these libraries directly. So maybe I'll add something like add a file or store a file or get a file. So get log will be get file or something like that. So right now it's initializing the Azure Storage Emulator, and if you see, you can actually go and see what's going on there. So it is creating everything locally. So this is the master. It created a master here. So this is the same console you would see in a virtual machine. Um, so you only have one instance of this. So it's still running, and we'll see. So you can see what's going on in the background, although you'll never get it fully. But there are few things here that comes sometimes, and if you print a message in the diagnostics, it'll show up here. So if you want to debug something, you could put a message there. But don't worry about these exiting, and then if you don't understand it, it probably is right. I mean, don't worry about it. So we have one instance of master and one instance of slave. That's what it shows. If you had multiple, then there'll be multiple lines like this. So it says role set unhealthy and then started. So it's starting up, it's booting and doing everything. So what is happening here is it's kind of emulating the behavior as if it is installing the operating system. It is getting your machine ready. So it created a virtual machine for you. It installed the software in it that can run your C# application, and that can run your Azure application. And then it'll so entry point called is the on start. It has called that. So monitoring as in stop and stop. So these are the things you shouldn't worry about, because I never did, and it worked fine. So we have this now. So here, I'll say and then here I say 30. And it's going to the value. So now let's put some error. So my queue. Now it says that object reference not set to an instance of an object. It's because message is null here, and then we said get this. So null dot add string is nothing. So we need to find out why was it null. So we coded it for the ideal situation where we won't get an error. Now because there is an error, we need to do something more. Oh, that did work. So it worked. What happened is that then it went to the while loop again for some reason. So we need to fix that. Let's see what happened. So message count probably was not reset to 0. How do I stop the code? Wait, stop button. Okay, so we did not reset message count to 0, right? So when you delete the message, you set your message count to 0. That's it. So when it comes here, it will never go past this. Huh? No, we want it to break when message count is not 0. So right now message count was 1, so it just went there.
Oh, I see.
And it didn't get a message, and it said, okay, read the string from this message.
So the larger while loop never terminates?
Yeah, that will never terminate, because you see, you will be clicking, you can get one sum, and then you'll get the second sum, and then you'll get the third sum. So the processor should keep working, looking for more work. So this time it will be fast because it already had the machine set up and stuff. So now it knows what to do. It will see, you didn't see that bunch of stuff that you saw earlier. It just starts at the process because the emulator was running. So it's not that bad. But we are still reading from the cloud though, right? Because our connection string connects with our cloud storage account. So we are putting a message in the cloud, well, in the queue somewhere.
Would it be easy if you had a couple different boxes set up,
Huh?
worker and web?
Say it again.
If you had 2 different boxes set up, machines, the worker and the web.
Better in one purpose. You said, would it be better, right?
No, it would be nice
It-
since you can send it to the cloud if your machines were in remote locations. You have a web role machine in one location and a worker in another.
So if you
in the
deploy your
cloud.
application, that happens.
Yeah.
So when we deploy it to cloud, that happens. But if you're wondering if I could have 2 laptops, one
Yeah.
working as web role and one as worker, I don't think you can do that. The emulator would not support remote machines.
Okay.
So I don't know. I'm pretty sure you cannot do that because emulator is pretty much for. Oh, on that there is something called Azure Blast, not Azure Blast. Azure Burst. They have something called Azure Burst. It's the same Azure for your on-premise cluster. So we could install Azure Burst on Cheetah, and then it will behave as if it is an Azure Cloud system. So that can happen if you install that.
Okay.
So let's see. Some and 60. Well, let's see. What we got. So we have a cloud-based calculator that does the sum, right? But this is pretty nice concept, right? For
Yeah.
a proof of concept. Now you understand how cloud works, and it's not that tricky. It's really very simple. Your code could be as complex as you want, and you just change a few things here and there. But basically, you just create a cloud-based application.
So does it automatically create that UI for you?
No, you have to do that yourself. So it gives you. Remember, we had that basic. So it gave you this one, and here it says "Welcome to ASP.NET" and stuff. So it creates that much. We just removed all that
Okay.
bunch of stuff, and then we added these text boxes, and we just left some button there.
So it's still using XAML.
Yeah, yeah.
Okay.
So any questions on this?
Pretty straightforward.
Pretty straightforward, right?
It's just like putting anything else in C# really. It's just the addition of the libraries
Yeah.
and stuff. It's pretty straightforward.
Right, right.
I mean, both of the work is done for you, so no, you're not smart. Shut up.
Alright, so I'll stop the video here, and if you want more, keep coming back to our website. I'm not going to tell you what website is it though.